Hi everyone. Today I'm coming at you guys with a bit of a shorter video. This video is intended to be basically an addendum to my video on mixed rules. I got a couple questions on that video about how you choose which rule you need to use first in the way that I did it in that video tackling those three different problems. So I think those of you who asked this were correct. I didn't really go much into detail into how to pick the rules. So I thought it'd be a good idea to make a follow-up video in which I pretty quickly go over a bunch of different examples and explain to you how I choose the order in which to use the rules. The rules I'm talking about, of course, are product, quotient, and chain rule. If you have to do more than one of these in the same problem, then you have to pick the order. And so this video is just focusing on how you figure out which order you need to do things in. I'm not actually going to calculate any of these derivatives, so I'm not going to work through any of these problems. I'm just going to go through how I know which order I need to do the rules in. Okay. So I'm going to go through each of these. I'm going to pause a bit to give you guys the opportunity, if you want, to pause the video and see if you can figure out for yourself what order to do them in. But otherwise, I'm just going to go relatively quickly through these, explaining my thought process. And the first example is a problem asking you guys to find the derivative of x e to the x squared. And the question is, of course, which rule do we use first? And my general rule for this, or my general guideline, I guess, is that the outermost operation should be the one that goes first. And basically what this means, in other words, is that you should see that one of the operations the operations I'm talking about, of course, are multiplication, division, and composition. Happens inside the other one. And that's what I mean when I say the outermost one goes first. And let's see how this works out in a couple examples. So this example number one, we have x times e to the x squared. And we see that we have a multiplication of two functions. And it just so happens that inside the second function that we have the multiplication in, we have a function composition. So if you look at it this way, you see that there is a multiplication. I'll say this the other way. We have a function composition that is happening inside the multiplication. Okay, so that means that the outermost operation is our multiplication, which means we should be using the product rule first. And second off, we're going to use the chain rule. Okay. This example is a good contrast, in my opinion, with the second example that I give here. So I'm going to write this one out. We're looking for the derivative of e to the x, And before you guys ask, yes, it's totally fine to have e to the x in the exponent of e. I could have a bunch of these. I could have e to the 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 x if I wanted to. Of course, in real life, you very, very rarely see that happening. So this is really more of just a sort of example to prove a point, I guess. All right, if you guys want to pause the video and see if you can figure out which order you want to do that in, go ahead and do that now. Okay. So in this case, we can see that we have a classic function composition type thing going on here. But it just so happens that within our function composition, we have this multiplication. So we have a multiplication inside a function composition. So that means that the outermost operation is the composition, meaning you need to use the chain rule. And inside of the chain rule is going to be a product rule. Okay, hopefully when you look at this example and compare it with the first one that I did in this video, you can see the difference. Hopefully it becomes a little bit more clear what I mean when I say that there's an outermost operation and an innermost operation. Hopefully you can see what happened when I swapped the order here in these two problems. All right, next up, we have our third example. So when we have 3x squared plus 2 divided by e to the x, natural log of x. All right, if you want to see if you can figure this out by yourself, feel free to pause the video. Okay, so in this one we see that we have a large division going on. And within the denominator, so in other words, within this division, we have a multiplication here. So here we have a multiplication that's happening in a division. And so this means that, we want to do the quotient rule first. And after the quotient rule, or inside the quotient rule rather, we'll have to do a product rule. Okay, now a cheap, sort of easy trick that works whenever you're dealing with trying to figure out the order, and you know that one of the two rules you're going to need to use is the quotient rule, is to look at the size of the fraction bar. So here in this problem, you can see that the fraction bar goes through the entire function. It's a very large fraction bar. When the fraction bar goes through the full function, that usually means that you're going to need to use your quotient rule first. If your fraction bar does not go through the full function, probably the quotient rule happens second. All right. So with that tip in mind, let's move on to our fourth example. Here we have the derivative of square root of 2x squared plus 3 divided by e to the x. Once again, if you'd like to try this out for yourself, feel free to pause the video. Okay, so once again, we see here that we have a very large fraction bar. The fraction bar is going through the entire function. And so that, like I said just earlier, that should be a strong hint to you guys that your outermost operation is the division and that you'll have to use quotient rule first. And indeed, if we look more carefully, we can see that inside the numerator, we have a function composition. So here we have a composition that is happening inside a division. And so that should be telling you that the quotient rule goes first, and that the chain rule goes second. Okay. Let's move on to the last example. Example number 5 that I have here is asking you guys to find the derivatives of x squared plus 3x minus 9 times e to the x over natural log of x. Okay, if you'd like to try to figure this out on your own, feel free to pause the video. Okay, so here we see that again we have a fraction, but this time the fraction bar is a lot smaller. It doesn't go through the entire function. And indeed we see that we in fact have a multiplication that's going on out here. And then within the second factor that we are multiplying by, we see that we have a fraction. So in this case, we have a division that is happening inside a multiplication. And this is telling you that the product rule happens first. And inside this product rule, we have a quotient rule. And again, the fact that the fraction bar was so small and didn't go through the entire function should be a very strong hint that the quotient rule should come second in this problem. Okay, that's all I wanted to cover in this video for today, and I'll leave it at that. The only extra thing I'd mention is that in some cases, and really caveat, this is only for those of you who are a bit more adventurous or a bit more inclined to be tricky. It is sometimes possible to do some algebra, move some things around, and be able to change which rule you need to use first. This is true in this last 5th example here, by the way. I only wanted to mention that because some of you guys may have seen this on your own. And if you did, I wanted to just emphasize that you guys are not crazy. There are sometimes multiple roads that lead to Rome. So for those of you who don't care about that stuff, who don't want to be tricky, who just want to figure out what's the one surefire way to do this, just do it exactly like I mentioned in this video. Figure out what's the outermost operation in the way that the function is expressed, and that should be the one that goes first. The second one is the one that happens inside the first one. Cool. All right, that's it for this video. Hopefully this helps clarify a bit what order you should be doing things in. And I hope everybody is staying safe and healthy at home, as always. And I'll see you guys in another video. Bye-bye.